Welcome to this Maths Made Easy video on cubics. To start with, let's take a look at method 1 on factorising cubics given one factor. Now when we're factorising a cubic expression, you will be able to put it into or up to 3 brackets. Now you may be given one factor that you can work with, which will make the factorisation easier. So if we take a look at this example here, we're told x minus 2 is a factor of f of x, and we're given this cubic expression. Hence, express f of x as a product of 3 linear factors. So, to start with, we need to write down the factor we know, x minus 2, next to another set of brackets. So what we've got here is x minus 2, and this is next to another bracket here. And what we know is this x minus 2 times this other bracket will give us f of x. So this is equal to 2x cubed plus x squared minus 13x plus 6. Okay, so straight away we know we have a 2x cubed here. Okay, well this is an x, so we know there must be an x squared at the beginning of this bracket, and specifically we need 2x cubed, so that means this first term here must be 2x squared. Okay, because this needs to multiply together with x from the first bracket to make 2x cubed, so that must be 2x squared. Now we find the constant term for the end of the second bracket, so this bracket here. Okay, this will need to be multiplied together with minus 2 to make 6. So in that case, that will simply be minus 3 there. Okay, minus 2 times minus 3 gives us positive 6. Now, the x and the minus 3 above multiply to make minus 3x, but we need minus 13x. So we need an extra minus 10x from somewhere. So we need to multiply minus 2 by 5x to make minus 10x. Okay, so in that case, that tells us our middle term here must be plus 5x. Okay, now we can check this works here by multiplying out both these brackets. And what we do find here is if you multiply these brackets together here, we actually get f of x. So we know this works. So here now, if we want to write this as a product of 3 linear factors, we just need to take this quadratic here and factorise that into 2 linear factors. So therefore, 2x squared plus 5x minus 3, well, we can write that as 2x minus 1 times x plus 3 there. Okay, so therefore, if we put all of this together then, what we obtain here is that 2x cubed plus x squared minus 13x plus 6 can be written as x minus 2 times x plus 3 times 2x minus 1 there. Okay, so that gives us everything we need there for method 1 on factorising cubics given one factor. Let's move on now to take a look at method 2 of factorising cubics using the factor theorem. Now if you were given no factors, then you can use the factor theorem to find one factor and then use method 1 as we did previously. Reminder, the factor theorem is defined as the following. So if f of x is a polynomial, we just jot this down here, so f of x is a polynomial and f of k equals 0, then we can say x minus k is a factor of f of x. So this is a factor of f of x. Or we could also say here, if f of b over a is equal to 0, then ax minus b is a factor of f of x. Okay, so this is a factor of f of x. Okay, and remember, when we're using the factor theorem here, you will need to try small values of k first. So for example, f of 1, f of minus 1, f of 2, etc., until you find f of k equals 0 to start with. So that gives us everything we need there for method 2 on factorising cubics using the factor theorem. And finally, let's take a look at cubic graphs. Now you can easily sketch a cubic if you know its factors. You just have to find where the function is 0. All cubic graphs have a general shape. If the coefficient of x cubed is positive, then the graph goes from the bottom left to the top right. And if the coefficient of x cubed is negative, then the graph goes from the top left to the bottom right. The y-intercept of a cubic graph, y equals ax cubed plus bx squared plus cx plus d, is simply the d value. So by expanding brackets, we can find where the graph crosses the y-axis. So here, let's take a look at 4 examples then. So let's say we want to sketch the graph of f of x equals x times x minus 1 times x plus 2. How would we do this here? Well, the first thing I know is that we have 3 solutions here to where this graph crosses the x-axis. We have when x equals 0, so when x equals 0. We have when x equals 1, so when x equals 1. And finally we have when x equals minus 2. Okay, and those solutions are obtained by setting f of x equal to 0. So therefore, if we sketch this, what we can also notice here is the coefficient of x cubed is positive. So we know our cubic will start in the bottom left and go to the top right. So sketching that, we get something that looks like this. So if we just remove the ink here, we can see that. Okay, we start in the bottom left, and we finish in the top right, and we cut through minus 2 like we mentioned, 0 and 1 there. Okay, so that gives us our first cubic graph. Let's say now we wanted to sketch, for example, g of x equals x plus 1 times x squared plus x plus 1. Okay, how would we do this? Well, again, we try and find where this is equal to 0. So if we set g of x equal to 0, we get one solution here, and that's x equals minus 1. We can't find any solutions here for x squared plus x plus 1. So our only solution then is x equals minus 1. So we know it's going to cut through the x-axis at minus 1. We can check the coefficient of x cubed here, which would be just 1. So we know that's positive. So we know it's going to start in the bottom left and go to the top right. And we also know here our value of d will simply be 1 times 1, giving us 1 there. So we know it's going to cut through the y-axis at positive 1. So if we put all of this together and sketch g of x, we get something that looks like this. We know that it cuts through minus 1 here and positive 1 on the y-axis. Okay, and we start in the bottom left and go to the top right there. Okay, so now if we take a look at, say, h of x, so h of x here, if we say this is 1 minus x times x plus 2 all squared. How would we sketch this? Well, here now, straight away, if we look for these solutions by setting h of x equal to 0, we notice we get a couple of solutions here. And what we get is 1 minus x equals 0, so therefore x equals 1. So we get x equals 1. What we also get here is x plus 2 squared equals 0. So what that tells us is that x equals minus 2. And this one here is a little bit special because this is a squared term. So what that means is that that's a repeated root at x equals minus 2. We also note here that this is a negative cubic. Our coefficient of x cubed is negative, minus 1. So in that case, we're going to start in the top left and go down to the bottom right. We also note here that in this case, this is x plus 2 times x plus 2 times 1 minus x. So in that case, d here is equal to 1 times 2 times 2, which is equal to 4. So we know that h of x will cut through the y-axis at positive 4. And if we put all that together then, what we obtain is something that looks like this. Notice we have our repeated root here at minus 2. We have another root at 1. And we know it cuts through the y-axis here at positive 4. And finally then, let's say we've got m of x. Okay, so if we erase that, let's say we've got m of x. Okay, so m of x. And let's say this is equal to 1 minus 2x cubed. How would we sketch this here? Well, again, we can just write this as a product of 3 lots of 1 minus 2x. That's 1 minus 2x times 1 minus 2x times 1 minus 2x. Okay, and this might help to kind of visualize this a bit easier. The first thing we can note is that it's going to clearly cut through the y-axis at 1, because we've got 1 times 1 times 1. Okay, so it cuts through the y-axis at 1. We notice then that we only have one solution here, so we set m of x equal to 0. We have 1 minus 2x, so 1 minus 2x equals 0, so therefore x is simply a half. Okay, so we know it's going to cut through the x-axis here at a half. And again, this is 3 roots here with this same solution. So we put all this together, and again, just notice now, minus 2x times minus 2x times minus 2x, that would give us a negative cubic. So we're going to start in the top left and work down to the bottom right again. And if we put all that together, we get something that looks like this. Again, noting that we start in the top left here and work down to the bottom right. We have our solution here of a half, and we know it cuts through that positive 1 there. Okay, so that gives us everything we need there for cubic graphs, and that concludes this Maths Made Easy video on cubics.